Hello, my name is Alicia Shapiro with AInews.com, and welcome to another episode of our Driving Tomorrow Conversations with Industry Leaders, where we explore the latest developments and newest innovations in the world of artificial intelligence. Today, we welcome Nova Spivack, a tech and AI visionary with over 30 years of innovation, currently leading Mindcorp.ai as the CEO and co founder. This Mindcorp.ai currently is operating in stealth mode, but is leading the industry in blending cognitive capabilities with AI to tackle complex tasks. We'll also explore Nova's latest work as the co-author of the paper Cognition is All You Need, the next layer of AI above large language models, which introduces cognitive AI as a crucial step forward in AI development. Our discussion today will cover the implications of cognitive AI, the future of AI, and the multidisciplinary approach fueling Mindcorp AI's breakthroughs. Thank you for joining us today, Nova.
Thank you. I'm glad to be here.
Could you share the vision that has led to the founding of Mindcorp AI and how it aims to reshape the landscape of artificial intelligence by enabling exponential intelligence?
Yes. So I've been working in AI for many decades. I started actually with Ray Kurzweil and then with Danny Hillis. I also worked with an intelligent agent company called Individual out of Carnegie Mellon, and then started one of the first internet companies, and then several AI-powered and big data-powered analytics companies. I worked on the DARPA Kalo project, which was the largest AI intelligent agent project in US history, out of which, among other things, came Siri on the iPhone.
Mm,
So I've worked on many different AI projects, and over these decades, there's been a pendulum that swings back and forth between two major approaches to AI. One approach is the neural approach with neural networks and probabilistic approaches to AI. And the other approach is a structured, a symbolic approach characterized, for example, by expert systems and analytics, big data, algorithms, and heuristics. So we've seen this pendulum every decade swing back and forth. And now here we are back at the probabilistic neural approach to AI,
right.
which we see in large language models. Our insight is that you can't really solve the hard problems of AI with just one of these approaches. You really have to
Right.
combine them. So we take a neuro-symbolic approach, which we call cognitive AI, which combines the best of both. You have large language models giving a probabilistic capability and language processing capability, but above them you have a cognitive layer that uses the symbolic approach, which is using formal knowledge representation, another layer of inferencing, and higher levels of what is called metacognition, which we'll talk about today.
Oh, that's very interesting. What are the most significant challenges you've encountered while developing your generative AI platform, Mindcorp, and how has these challenges influenced breakthroughs in AI technology?
Well, we're focused on a particular set of problems in AI around high-level knowledge work. This is the kind of
Okay.
knowledge work that typically you would see, higher-level white-collar knowledge workers in the C-suite, heads of departments, managers, directors, leaders. The kinds of questions that they are solving are very complicated. They usually have multiple steps of reasoning, research, analytics. They're very complex problems. And for example, they might be strategy or planning for an enterprise. These problems cannot easily be solved just inside of a large language model because large language models are limited, first of all, in the size of their context windows, how much knowledge they can actually process, but also they tend to become less accurate as they iterate over many, many steps in a complex problem. And so to get around those limitations, you have to take this other approach. And so when we first started this, just looking at large language models on their own, we quickly found these limitations. We had to innovate outside of the model to solve these problems. And that's really the essence of our platform and what we're focused on.
That's really cool. With Mindcorp focusing on facilitating collaboration between humans and cognitive agents, how can you elaborate? Can you elaborate on how this interaction enhances strategic planning and innovation in complex knowledge work?
Yeah, I can do that. In fact, it might be helpful to show a bit of a presentation that goes with our archive paper.
Oh, sure.
Um,
Yeah.
so let me just share my screen. Okay. So we have a paper in archive called Cognition is All You Need.
Mhm.
And I'll just take you through some of the reasoning that mirrors the paper, and I think it will elucidate some of the reasons for our platform and what we're doing.
Great.
So the first point is that today, as we know, AI is really focused on large language models, and large language models, typically have this token-oriented approach. For example, whether it's OpenAI GPT or Anthropic with Claude or Google Gemini and so forth, they all kind of work the same way. You have a stream of input, AI processes that and produces a stream of output tokens. The key here is that in conversational AI, it works like a simple circuit.
Mhm.
The system basically loops around, taking the last message as the input, and generates a new message. And to make this a little bit more sophisticated, you can add in things like vector databases and embeddings, so that you can do retrieval augmented generation, which is also called RAG, to enrich what the model is capable of responding to in a given input. And this is pretty much the state of the art today, whether you're looking at
Mhm.
ChatGPT or Google Copilot or whatnot. But if you try to use chatbots and this simple circuit methodology for anything more than a simple chat, you really have to be a prompt engineer to
Mhm.
get really sophisticated answers out of a system like this. But we all know that prompt engineering is an art that's hard to master.
Mhm.
Most knowledge workers aren't going to have the skills or the time to learn how to do that. So to
Right.
really get answers to complex questions, you can't require the knowledge workers to also, essentially become linguistic programmers. And it gets even more difficult when you apply this to hard knowledge work problems like research, analytics, strategy, planning, innovation, design, project management, and consulting, and so forth. If you try to work on problems like that, of that scale, prompt engineering isn't enough. Even if you're a world-class prompt engineer, getting a chatbot to perform well on this is really hard. And one of the reasons is that large language models don't really reason. They don't really think. They're just using probabilities. A lot of people don't really understand this, and they impute onto these models thinking and cognition, which they're not really doing. These models aren't
Right.
really doing that. They're just mimicking that. And there's a huge difference.
Mhm.
Real knowledge work, real higher level thinking needs to use cognition, which is the ability to manage your thought process, not only to think. You have to think about your thinking. You have to work
Mhm.
on a higher level.
Right.
So the interesting point is that large language models are not even theoretically capable of cognition. And this is because large language models find the most probable solution. But in real cognition, you're trying to find optimal solutions. And those are not necessarily the most probable solutions.
Okay.
Sometimes the optimal solution is less probable. It's not the thing that you would automatically generate from a model. Sometimes you have to iterate, you have to explore different solution paths, you have to backtrack, you have to explore a search tree, you have to do things which are more complicated than just a probabilistic answer. So that is why large language models on their own won't be able to do this. And they won't be able to generate, for example, AGI. That will not happen inside of a model. It will only happen from outside the model. So real thinking, in other words, cognition, has to happen and can only happen above large language models. So we define these sort of phases of AI. There was algorithmic AI, really that was in the 80s and 90s. And it even kind of moved gradually through the semantic web and formal language processing, eventually reaching transformers, which enabled conversational AI, which is where we are today.
Okay.
But there's a chasm ahead of us, what we call the cognitive chasm, to reach cognitive AI, which will be capable of these higher level tasks. Now, to cross this cognitive chasm, we need a different kind of model or a different kind of architecture. And so I'm going to talk a little bit about the functional architecture, which is the roadmap for cognitive AI. So
Okay.
in essence, you've got an intelligence layer with models in it. And it could be more than one model for different tasks. Above that, you have the cognitive layer. And this cognitive layer is capable of meta intelligence, also called metacognition. We'll talk about that a little bit. And that's what you need to have a real cognitive AI application. You need these two layers. We call it a dual layer architecture. So cognitive AI orchestrates knowledge work among humans and AI agents. It works at a higher level. But these apps are very complicated and difficult to implement. So there are really no mature products today that can do it, not for end users, not even for developers. Even the agent platforms today are very low level, and they're working in that direction, but they don't have all of the capabilities that they need to have a mature platform level solution to this problem. So let's look at an example. To make a cognitive AI system, for example, let's say to do IP development and monetization, first, you have to build some components. So let's make a little innovation component here. It can brainstorm, it can refine ideas, it can evaluate ideas, and it can select best ideas. Now, you could probably do that with a prompt. It would be simple, but you could do it with a prompt. But above that, you want to make an agent, an IP developer agent. And this agent takes that component that we made, which was just a piece of it, and it integrates it with other things, analysis, innovation, making specifications, doing design, doing development. There's some magic underneath to make the agents work, but that's just one agent. Now, when you do this, the next thing is to enable multiple agents to interact and work together as teams. So you have the ability for agents to talk to each other. And we do see some agentic platforms starting to do this. But again, they're sort of very low level solutions, sometimes just focused on a special case and really aimed at developers. Now let's take that a little further, and let's say we have that agentic platform and we have these agents. Next, we want to connect them into collaborative teams that can work on complex projects together. So here, to make a team of agents that could work together, you have to now add another layer to coordinate the work of the agents. So workflow, to coordinate how they work together, project and knowledge management to coordinate how they manage projects, how they manage the resources of projects, and a system to orchestrate all of this into some kind of meaningful process that can solve problems. So if you put it all together, the final missing piece is, how do humans participate in these projects? So you want to have a human in the loop solution, because ultimately agents don't know everything, and they don't necessarily have the nuance or organizational experience and wisdom that the humans bring to these projects. And so in real knowledge work, you need to have humans in the loop. So you have to have a system that can connect these teams of different types of agents with teams of humans, one or more humans, sometimes groups of humans, working together in synchrony to work on these complex problems. That's very impressive. If you can do that, that's great. But that's just one vertical case. What about the general solution? So there is no platform other than ours that we know of that can really do this and provide a user experience that doesn't require everyone to become a programmer. And this is where Mindcorp comes in. So our platform, which is called Cognition, is a cognitive AI platform for everyone. It's really aimed at knowledge work and high-level knowledge work. It's a SaaS, AI-powered knowledge work platform that anyone can use. And it helps you collaborate with teams of agents and people to do knowledge work together. Under the hood, there's a fully featured enterprise-grade cognitive AI platform with many innovations in it. And this is the functional architecture. So on the left here, we have the conversational layer from the LLMs. The LLMs are basically providing almost like electricity to the system. Language processing is kind of like electricity. It's a capability that these systems use. So on the right here, we have the cognitive layer. And this is where the cognition above and outside the large language models takes place. Some of the key functional components of a cognitive AI architecture are outlined here. They can do research, looking at external data. They can do reasoning and analytics above the model, outside the model. They're using the model, they're using language, but they're guiding the flow of that linguistic activity through heuristics that live outside the model. Project management and planning are very, very key. To do any kind of high-level reasoning or problem solving, you have to be able to plan how you're going to solve the problem, how you're going to think it through, how you're going to collaborate to do it. Tool use or tool utilization with a tool manager that can manage tools and bring them into a project and orchestrate them and use external APIs and apps to do that. An execution manager which guides how the system plans and executes its work, even if the ability to self-improve or react to or reflect on what it's doing and adjust its approach to reach results in a more optimal way, or to navigate around roadblocks or problems that are encountered along the way. Dialogue management is how you manage the discussions both between the humans and the agents and the agents, and the entire team as a group. The agent manager, which is how you create and manage agents, relationship management with humans, and context and knowledge management for dealing with the data that's in the scope of the current activity that you're working on. So this is a functional architecture, and you could say it's kind of like a very uh, powerful integrated circuit where you have, electricity flowing in from the LLMs, and it's flowing through these complicated circuits in this system to do very high level reasoning. Now, if we look at it a different way, and we kind of look at our platform, there's a bunch of capabilities. We manage agents. We call them ACEs, artificial cognitive entities. We manage teams of them. We manage the knowledge, the projects, the chats and discussions, and many different kinds of things that come from that. Now, one of the things that we've done in Cognition is we've built 10,000 ACEs. So we've built 10,000 AI copilots that model the skills, expertise, personalities, approaches, heuristics, knowledge of professionals in different fields and roles. And so these 10,000 professionals already exist and model these capabilities, and we can bring them to bear on these projects. And the way we did that is we analyzed all of these different industries and job functions, and we actually created agents to model these professionals in these different roles. So the result is that the system is better than any chatbot or large language model. It can do knowledge work at a level that you cannot get out of a model on its own. So this really is the next big thing after chatbots. And this is, in our opinion, it's what's next after conversational AI. Now, how does this work? Well, Cognition makes it seem like magic. There's no prompt engineering, there's no coding. The system and the ACEs figure this out on their own. And this lets you focus on your actual work instead of making the tools work. Instead of learning how to use the tools, you can just do your work. So in this case, Cognition is really designed for sharing. It has built-in network effects. It's not vapor. This is real. We have large enterprises already using it. We're still in stealth. We haven't shown it publicly, but it's real. And in order to get better results from AI, we believe every knowledge worker really needs Cognition. And once they see it, when we show this, they always want it. One of the things to note is that, if you just kind of look at the world, you kind of have a lot of innovation around conversational AI, but the cognitive level of the systems is still pretty basic. So this is where we're innovating. And this is why we think cognitive AI is essential and is the next step. And if you think about the crossing the chasm methodology, the cognitive chasm is what's right in front of us now. The minimal feature set of large language models now exists, and it works very well. But to get to whole product solutions that can solve the problems that the early and late majority have, the big companies of the world, that's where we have to cross the cognitive chasm. So cognitive AI is the next trillion-dollar AI opportunity. But to get there, we have to go beyond LLMs. LLMs are basically becoming a commodity today. And we see the rise of open source models becoming extremely good. Within a year or two, they'll be as good as the large commercial models. And the only way the large commercial models will be able to differentiate at that point, the private models, is they'll have to go up market and become more expensive and work on larger and more expensive kinds of inferencing. And so that's great, but only some companies will be able to afford that. So to really bring cognitive AI to everybody, you can't just rely on whatever it will be, GPT-5 or GPT-10. You need a cognitive layer that can take an open source model and make it even more powerful than a GPT-5 or a GPT-10. And this is the new frontier. It's going to be a new IP landscape. There's going to be a lot of innovation in this area. You cannot get to cognitive AI directly from conversational AI. You need to spend money. You need to build this next level platform. And that's how you get to AGI and ultimately to superintelligence. And the payoff is massive. If you can do this and really solve the problems of knowledge work, and I mean high-level knowledge work, overcoming these limitations, it not only gives you a more practical path to AGI, but it makes AI more actionable today. And to put this in context, if we look at the evolution of intelligence over time, you can say on one dimension, the level of meta-intelligence, the level of ability to self-reflect and think about thinking, is one of the key dimensions that we see higher forms of intelligence improving on. And then you have the level of intelligence itself. And so here you can kind of see insects, the superorganisms, social insects, moving up the scale up to whales, intelligent mammals. Conversational AI is a little less intelligent than a human. Then you get to humans. To get beyond humans, ultimately to AGI or enterprise general intelligence, which we call EGI, And finally, to superintelligence, you need to cross the cognitive chasm here to make cognitive AI enable groups to be collectively more intelligent and then leap up to the next level. So this is what we're doing. We're trying to cross the cognitive chasm, and we think we've actually solved it.
Hmm.
So we've actually got this working with some big companies. It's pretty impressive, and I think it'll be an important contribution to the field.
Oh, for sure. That sounds so exciting. It's like the future's already here.
It's coming.
Yeah, that's great. So given the advanced capabilities of cognitive AI, particularly in complex problem solving and strategic planning areas, what do you see as the main challenge in adapting cognitive AI technology for real world applications across different sectors? And how does Mindcorp plan to address those challenges to have a broader adoption and effectiveness?
So one of the things that the cognition platform does is the teams of ACEs, these artificial cognitive entities, um, engage in a dialogue with the user about what they're trying to accomplish. What's your goal?
Hmm.
The user says, for example, I want to come up with a strategy to make Disney the leading AI-powered entertainment company and triple their market cap in 10 years. The system says, okay, well, based on what you're trying to do, first of all, I have a whole bunch of questions for you that I need to ask you about, constraints, definitions, other budget, other kinds of issues and things you want to consider. So at first, it will actually, just like a consultant would, it will really work with the user to try to define exactly what they are asking for, what the outcomes are, and really get this scope the project the way a consultant would. And then after that first intake step happens, it actually generates a project. The project
Wow.
includes an entire strategic plan. It could be 50 steps or 100 steps for this team of ACEs and the humans involved to collaborate together to do the project. Once that plan is made and everybody agrees on the plan, then they start working on the plan step by step together.
Wow.
So the ACEs and the humans work on each step and they have meetings. And in these meetings, the teams of ACEs, which are, a group of professionals, virtual professionals, talk to the humans, talk with each other. They come up with strategies. They do research. They generate models and plans. They come up with approaches. And ultimately, they get feedback and they get approvals just the way that a team of consultants would. And so they work with the humans to go through this whole process. And the key is they can do this for any process. The system knows all the best practices for solving any kind of problem at this level, whether it's a management consulting type of problem, business transformation, screening for acquisitions or competitors, trying to do a product launch or a market entry plan, a business plan, or a major new innovation and how to develop that, design it, do the research, prove it, develop it, and bring it to market. So the system really knows how to do this. And the key is that it's really collaborating, it's co-working, or it's co-intelligence working together with the humans. It's not only AI, it's not only humans, it's the team working together. And so
Oh,
we
cool.
can bring this to bear on really any kind of problem at the enterprise level.
That's amazing. And in your opinion, what are the most critical ethical considerations we need to pay attention to as AI technologies become more integrated into our everyday functions?
Well, I mean, first of all, I am not an advocate of just hitting run and walking away and coming back, a week later and having everything done. I think
Yeah.
AI makes mistakes. It doesn't see the same nuances that humans might see. So it's first of all, it's very important when we design these kinds of systems to make sure that there is a human in the loop component. I think from an ethical standpoint and a safety standpoint, having humans in the loop is probably the most important thing, the most important guardrail that can really be put in place. There can be guardrails in the models, but ultimately, big decisions always should have a human approving them. There should be human oversight. So, the first answer is when in doubt, ask a human.
Yeah.
But secondly, before you do anything that has major implications, ask for permission, ask for approval, ask for feedback. So our systems are really designed to ask humans to approve certain kinds of actions or just simply large sets of actions that might have implications for an enterprise And so they really need to be approved first. So we're not trying to just automate everything. We're certainly trying to automate big pieces of knowledge work, but ultimately we're trying to make this fit in with how organizations actually work. They really work this way. In organizations, there's a whole set of checks and balances. There's a whole command and control hierarchy, and AI has to integrate with that and know how to work with that.
Right. And you kind of touched on this a little bit, but what are your hopes for cognitive AI's development over the next decade, and how do you see it changing the way we live and work?
Right now, we see many, many different agentic platforms and applications emerging.
Mhm.
There's a tremendous amount of experimentation and innovation taking place. There are many, many frameworks coming out. Not all of them see all of the essential pieces of the roadmap that I showed. They don't all have all the functional boxes in that functional architecture. So first of all, I think we need a general awareness of, for something to qualify as cognitive AI, what capabilities does it really have to have in order
Yeah.
to effectively get out of the box that large language models creates. How do you think outside of that box? Well, you have to have the ability to have, for example, metacognition, where it can think about its own thinking. It can react to itself. It can self-improve. You have to have knowledge representation, which means not just knowledge in a model, which is a bunch of probabilities, which is almost like instincts, but
Mhm.
knowledge which is formally represented in a structured way, and that can be learned and improved during a project. One of the things right now with large language models is you can't really train them while you're working on them. You can use them
Mm.
with the training they have. But if you compare that to a knowledge worker, they can learn, they can get new skills all the time on the fly. You don't have to stop, turn off the human, train the human, turn them back on, and then interact with them with their new training, right?
Mhm.
So these systems have to actually be able to collect and integrate new knowledge while they're working. And that doesn't just mean, a couple little snippets and using RAG to get those snippets back. It means actually formally collecting knowledge and representing how that knowledge connects with other knowledge that you have, and then being able to use that in a very nuanced way. For example, you might get some knowledge that conflicts with knowledge you previously had. You have to be able to resolve those conflicts. You have to be able to understand this implies that. However, there's an exception, and here's the exception. You have to understand things like rules and exceptions to rules. You have to understand conditional logic, not just probabilities. So the the field, as it matures, has to develop a clear idea of the difference between cognition and just intelligence. We're getting intelligence already out of the models, but cognition is a higher form of intelligence. It's intelligence about intelligence.
Mhm.
And the functional architecture of that is really key to not only crystallize as separate from the models, but also define into its big major functional units, which is what we did in our paper. And it's also what we're doing in our platform. So I hope that the field, as AI develops and it matures and inevitably moves towards cognitive I hope that the field, will converge on an understanding that this really is a different layer. Right now,
Yeah.
this understanding is not out there. It's not clear. People conflate cognition with intelligence, and they don't know the difference. They talk about AGI emerging out of an LLM. And if you
Mhm.
really have if you really have a deep and subtle understanding of this, that is just impossible. And it's clear
Mhm.
that it's impossible. As I said before, because LLMs really don't reason, they don't think, they don't know, they don't understand, they don't really think about their thinking. They can mimic it, but only within a few iterations, and then it starts to get inaccurate. So, when you really want to get into large, recursive, complicated thinking, you've got to have this higher level capability. That has to be very clear. And so the first thing is to make the case, to make it clear that this is different from LLMs, uses LLMs, needs them, but is above them. And even just that insight alone is a paradigm shift, because
Right.
then it starts to shift the focus to what's next.
Mhm.
And what's next is beyond LLMs. I mean, LLMs are very, very important, but I actually think we'll see diminishing returns from innovation on LLMs. I think they're already good enough for cognitive AI.
Mm.
We don't necessarily need GPT-5. I mean, it'll be great. We'll use it.
Yeah.
We'll be happy to use it. But
Mhm.
a very powerful cognitive AI system using just the level of LLMs that exist today will be capable of a much more advanced form of intelligence than an LLM that is a lot more advanced. So we'll be able to get farther with the cognitive AI approach than with LLMs on their own. And as a result, and because of the fact that LLMs are becoming commoditized, it's getting very noisy out there. Um, I think that from an investor perspective and a strategic perspective, as let's say an enterprise thinking about what technologies to invest in around AI, um, there will be more bang for your buck really by focusing now on what's after LLMs. We have LLMs. What's after LLMs? What's beyond LLMs? That's cognitive AI.
Wow, that is just so exciting. Can't wait. Shifting gears a little bit from the innovation and the transformative impact of cognitive AI, I'd like to get to know you a little better. When you're not busy working at Mindcorp, what could you share with us what activities or hobbies you're passionate about in your free time?
My biggest hobby in my free time has been trying to create a backup of civilization
Uh,
and put that all over the solar system with my
wow.
foundation, yeah, which is called the Arc Mission Foundation, arcmission.org. And it's sort of related in that we've been collecting vast amounts of knowledge and backing it up in these indestructible archives and storing them on places like the moon. We landed it on the moon twice now, including the Wikipedia and many other things. So that's my kind of free time activity is really backing up civilization and its knowledge.
That's fun too, though, I
A
think.
fun hobby.
Yeah. I mean, we got to ensure the human race, keeps going.
That's right, just in case AI wipes us out.
Yeah. Right. And then drawing from your experience, what advice would you give to aspiring entrepreneurs and people in the AI field who wish to make a significant impact like you have?
Well, I mean, I've worked on it for many, many decades and I've seen it go up and down. There's always a hype cycle, there's always a trough of disillusionment, then there's another hype cycle. You really have to take the long view here and play the long game.
Yeah.
I would say, number one, my biggest piece of advice is try to get profitable as fast as you can, instead of relying only on venture capital, which is in our case, we're in revenue and we're heading in that direction.
Nice.
With this company, we decided let's go for the revenue side of things instead of just going out and raising tons of money. So that's very important because you can control your own destiny. But it also gets you very close to the customer and their real needs. You learn from customers. So getting customers as soon as you can is really, really an important move as an entrepreneur. The sooner you're getting real feedback from real users, the more you can start to really tune for product market fit.
That's great. Um, So, Nova, thank you so much for sharing your groundbreaking work and vision of MindCorp. It's definitely shown the transformative potential of cognitive AI and underscores the connection between humans and technological innovation. So, thank you again for your time and inspiring us with your dedication to forward-thinking approach.
Thank you very much.
And you can sign up for the wait list to be notified when MindCorp launches and their cognitive AI product by going to mindcorp.ai. Thank you again for joining us, and we look forward to bringing you more conversations of AI's impact on our world. Keeping you connected to tomorrow. Today, this is Alicia with AInews.com.